Let's train a machine learning model. It can be something extremely basic, like recognizing patterns of numbers. In this example from the book AI and Machine Learning for Coders, we train a model using Tensorflow to recognize a pattern between these two sequences of numbers. We have X and Y values. And here, the task is that basically train a model to figure out the relationship between any given X and Y value. In this case, the actual relationship is Y equals 2X minus 1. In other words, for any given X value, we would expect the accompanying Y value to be 2 times that X minus 1. Right? But we want the computer to figure this out on its own. So there are a few ways to get started with TensorFlow. Probably the easiest is to open up a new session in Google CoLab so that all of the back-end processes are automatically set up for you. And throughout this process, we're going to be using a library in TensorFlow called Keras. I don't know if I'm pronouncing that correctly, but it provides a number of APIs that will be extremely useful for us. First, we're going to create a model by pulling out sequential. And when we call sequential, basically what we're saying is that we want to create a model by creating layers sequentially, by stacking these layers. And so in a deep learning model, which is what we're creating here, each layer of neurons takes in data, makes some guesses, and feeds that data to the next layer. And it just so happens that in this particular model that we're building right here, it's extremely simple. So we're actually only going to need one layer. And in that layer, we're only going to need one neuron. And here inside of our sequential call, we're going to create this single layer, and we're going to use the Dent API. And what Dent is, it means that basically each neuron in each layer is going to point to every single other neuron in the next layer. And in the first layer, we always have to specify the shape of the input, which in this case is a single value. It is our X value, which is an array of numbers. It's a single value, a single array. And so basically every time the computer makes a pass through these layers of neurons, it makes a guess as to what is the relationship between each X and Y value. And that's the purpose of the optimizer. It makes these guesses. It then attempts to measure how good or bad that guess was using a loss function. Both of these pieces that we are implementing here, the optimizer and the loss function, that's a much deeper rabbit hole to go down. If you're interested in mathematics, I recommend checking that out. For the purposes of what we're doing here, we're just using these already pre-built pieces. You can kind of think of it as being very similar to, if we're building a front end, right? We're doing some JavaScript stuff, and we might use a pre-built JavaScript library. When someone has already built a very robust library, it's much easier to use that library rather than to reinvent the wheel. And so each time that the computer makes a pass, it makes a guess. So maybe the first time through, it's Y equals 10X plus 10. So it compares this guess against each X and Y value, and it tweaks the parameters to try to figure out what these figures called the weight and bias are. And we can begin the actual machine learning process by formatting our X and Y values into NumPy arrays, and then we can pass these into the model. And epochs basically just tells the computer how many times we want the optimizer and the loss function to refine their guesses. So in this case, we're saying 500 times we want to run this process. And so now when we run this, by the 500th epoch, the amount of loss has gotten extremely small. And this tells us that the machine has basically learned the relationship between X and Y. And if it reached a loss of 0, we would know it had figured out the relationship with 100% confidence. So now that we have a trained model, we can feed it a new X value, and it should be able to predict based on that X value and based on its training what the accompanying Y value should be. And if we run this, we can see that it predicts the Y value to be just under 19 in my case when I ran it. It might be slightly different for you because the initial guess, the first guess, is always randomized. So there's some variation. In this case, it's just under 19, which is really close to what we would expect if we plug our X value into the formula Y equals 2X minus 1. And remember, our model still has some amount of loss, albeit very small. So the discrepancy here between 19 and what the model actually spit out in our case is pretty much exactly what we would expect.